Hello everyone, I am Zubair Ahamad, studying BE Computer Science and Engineering at SETHU Institute of Technology. In this video, we are going to see about Hadoop in Big Data. Let's get into the topic. At the end of this video, you will come to know about what is Big Data, application of Big Data, what is Hadoop, subject projects of Hadoop, Hadoop architecture, topology in Hadoop, features of Hadoop. Okay, now what is Big Data? Big data is a collection of data that is huge in volume yet growing exponentially with time. It is a data with so large size and complexity that none of the traditional data management tools can store it or process it efficiently. Big data is also a data but with a huge size. Following are some of the applied areas of big data: banking and securities, communications, made and entertainment, healthcare providers, education, manufacturing and natural resources, government and insurance. These are the applied areas of big data. Okay, now let me see what is Hadoop. Apache Hadoop is an open source software framework used to develop data processing applications which are executed in a distributed computing environment. Applications built using Hadoop are run on large data sets distributed across clusters of commodity computers. Commodity computers are cheap and widely available. These are mainly useful for achieving greater computational power at low cost. Similar to data residing in a local file system of personal computer system, in Hadoop, data resides in a distributed file system which is called as Hadoop distributed file system. The processing model is based on data locality concept, where computational logic is sent to cluster nodes containing data. This computational logic is nothing but a compiled version of a program written in a high-level language such as Java. Such a program processes data stored in Hadoop HDFS. Okay, now let me see. Apache Hadoop consists of two sub-projects. They are Hadoop Map Projects and HDFS. What is Hadoop Map Project? Okay. Now let me see about Hadoop MapReduce. MapReduce is a computational model and software framework for writing applications which are run on Hadoop. These MapReduce programs are capable of processing enormous data in parallel on large cluster of computation nodes. After Hadoop MapReduce, the second one is HDFS. It means Hadoop Distributed File System. HDFS takes care of the storage part of Hadoop applications. MapReduce applications consume data from HDFS. HDFS creates multiple replicates of data block and distributes them on compute nodes in a cluster. This distribution enables reliable and extremely rapid computations. As we all know, Hadoop is a framework written in Java that utilizes a large cluster of commodity hardware to maintain and store big size data. Hadoop works on MapReduce programming algorithm that was introduced by Google. Today, lots of big brand companies are using Hadoop in their organization to deal with big data. For example, Facebook, Yahoo, Netflix, eBay, etc. These companies are used Hadoop to organize their dealing with the customers. Okay, these Hadoop architecture mainly consists of four components to work with. They are MapReduce, HDFS, it means Hadoop Distributed File System, Yarn, it means yet another resource negotiator, and common utilizers or Hadoop common. These are the four components of Hadoop architecture. Let us understand each one of these components in detail with one by one. Okay, first we will see about MapReduce. MapReduce nothing but just like an algorithm or a data structure that is based on Yarn framework. The major feature of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which makes Hadoop working so fast. When you are dealing with big data, serial processing is no more of any use. This MapReduce has mainly two tasks which are divided in phase-wise. One is first phase and another one is second phase. In first phase, map is utilized and in next phase reduce is utilized. Okay, so here we can see that the input is provided to map function, then output is used as an input to reduce function, and after that we receive our final output. Let's understand what is map function and reduce function does. As we can see that an input is provided to the map function. Now as we are using big data, the input is a set of data. The map functions here breaks this data blocks into tuples that are nothing but a key value pair. These key value pairs are now sent as input to reduce function. The reduce function then combines this broken tuples or key value pair based on its key value and forms set of tuples and performs some operation like sorting, summation, type job, etc., which is then sent to the final output node. Finally, the output is obtained. The data processing is always done in reducer depending upon the business requirement of that industry. This is how first map function and the reducer is utilized one by one. Okay, let us understand the map task and reduce task in detail. After the completion of map reduce, now we are going to see about map task and reduce task. Okay, what is map task? Before going through what is map task, we have to see the four components in the map task. They are record reader, map, combiner, partitioner. These four types are included in the map task. Okay, what is record reader? The purpose of record reader is to break the records. It is responsible for providing key value pairs in a map function. The key is actually its locational information and value is the data associated with it. What is map? A map is nothing but a user-defined function whose work is to process the tuples obtained from record reader. The map function either does not generate any key value pair or generate multiple pairs of these tuples. Combiner is used for grouping the data in the map workflow. It is similar to a local reducer. The intermediate key value that are generated in the map is combined with the help of this combiner. Using a combiner. Okay, what is partitioner? Partitioner is responsible for fetching key value pairs generated in the mapper pieces. The partitioner generates the shards corresponding to each reducer. Hash code of each key is also fetched by this partition. The partition performs its hash code models with the number of reducers. Okay, after map task, now we are going to see reduce task. In reduce task, there are three components, namely shuffle and sort, reduce and output format. Okay, let me go through about shuffle and sort. The task of reducer starts with this step, the process in which the mapper generates the intermediate key value and transfers them to the reducer task is known as shuffling. Using the shuffling process, the system can sort the data using its key value. Once all the mapping tasks are done, shuffling begins. That is why it is a faster process and does not wait for the completion of task performed by mapper. Reduce. The main function of task of the reduce is to gather the tuple generated from map and perform some sorting and aggregation sort of process on those key value depending on its key element. And last one, output format. Once all the operations are performed, the key value pairs are written into the file with the help of record writer. Each record in a new line and the key and the value in a space separated manner. Okay, these are the main things in map task and reduce task. Okay, we have completed that both the map task and reduce task, and now we are going to see about HDFS, Hadoop Distributed File System. What is HDFS? HDFS is utilized for storage permission. It is mainly designed for working on commodity hardware devices working on a distributed file system design. HDFS is designed in such a way that it believes more in storing the data in a large chunk of blocks rather than storing small data blocks. HDFS in Hadoop provides fault tolerance and high availability to the storage layer and the other devices present in the Hadoop cluster. Data storage nodes in HDFS, name node and data node. These are the two components in the HDFS. Let me go through about these two topics. Okay, let me see about the name node first. Name node works as a master in a Hadoop cluster that guide the data nodes. Name node is mainly used for storing the metadata. That is, the data is about the data. Metadata can be transaction logs that keep track of the user's activity in a Hadoop cluster. This name node is wisely called as a master. Okay, and then data node. What is data node? Data node works as a slave data node or mainly utilized for storing the data in a Hadoop cluster. The number of data nodes can be from 1 to 500 or even more than that. The more number of data nodes, the Hadoop cluster will be able to store more data. So it is advised that the data node should have high storing capacity to store a large number of file blocks. Data in HDFS is always stored in terms of blocks. So the single blocks of data is divided into multiple blocks of size. 128 MB is default and you can also change it manually. Let's understand this concept of breaking down a file in blocks with an example. Suppose you have uploaded a file of 400 MB to your HDFS. Then what happens is this file got divided into blocks of 128 MB plus 128 plus 128 and 16 MB is equal to 400 MB size. Means 4 blocks are created each of 128 MB except that last one. Hadoop does not know or it does not care about what data is stored in these blocks. So it considers the final file blocks as a partial record as it does not have any idea regarding it. In the Linux file system, the size of a file block is about 4 KB, which is very much less than the default size of file blocks in the Hadoop file system. Okay, now let me go through about read and write operations in HDFS. Read and write operations in HDFS operate at a block level. Data files in HDFS are broken into block size chunks which are stored as independent units. Okay, let me see about read operation in HDFS. What is read operation in HDFS? Data read request is served by HDFS, name node and data node. Let's call the reader as a client. Below diagrams depicts file read operation in Hadoop. A client initiates read request by calling open method of file system object. It is an object of type distributed file system. This object connects the name node using RPC and gets metadata information such as location of blocks of file. Please note that these addresses are of first few blocks of a file. In response to this metadata request, addresses of the data nodes having copy of that block is returned back. Once addresses of a data nodes are received, an object of type FS data input stream is returned to client. FS data input stream contains DFS input stream which will take care of interactions with the data node and name node. In step 4 shown in the above diagram, a client invokes read function method which causes DFS input stream to establish a connection with the first data node with the first block of a file. Data is read in the form of stream where client invokes read function method repeatedly. This process of read function operation continues till it reaches the end of a block. Once the end of a block is reached, DFS input stream closes the connection and move on the locate to next data node for the next block. Once the client has done with the reading, it calls a close function method. So these are the read operations in HDFS. After the completion of read operations, now we are going to see about write operations in HDFS. Okay, in this section, we will understand how data is written into HDFS files. A client initiates write operation by calling create function method of distributed file system object which create a new file. Step number 1 in the above diagram. Distributed file system object connects to the name node using RPC call and initiates the new file creation. However, this file creates operation does not associate any blocks with the file. It is the responsibility of name node to verify that The file does not exist already and the client has correct permissions to create a new file. If a file already exists or client does not have sufficient permission to create a new file, then IO exception is thrown to the client. Otherwise, the operation succeeds and a new record for the file is created by the name node. Once a new record in a name node is created, an object of type FS data output stream is returned to the client. A client uses it to write data into the HDFS. Data write method is invoked in the step 3 of the diagram. FS data output stream contains DFS output stream object which looks after communication with the data nodes and name node. While the client continues writing data, DFS output stream continues creating packets with this data. These packets are enqueued into a queue which is called as data queue. There is no more component called data streamer which consumes the data queue. Data streamer also asks name node for allocation of new blocks, thereby picking desirable data nodes to be used for replication. Now the process of replication starts by creating a pipeline using data nodes. In our case, we have chosen a replication level of 3 and hence there are 3 data nodes in the pipeline. The data streamer pours packets into the first data node in the pipeline. Every data node in a pipeline stores packet received by it and forwards the same to the second data node in a pipeline. Another queue, it means ACK queue, is maintained by DFS output stream to store packets which are waiting for acknowledgement from data nodes. Once acknowledgement for a packet in the queue is received from all the data nodes in the pipeline, it is removed from the ACK queue. In the event of any data node failure, packets from this queue are used to regenerate the operation. After a client is done with the writing data, it calls a close function method called to close function, results into flushing remaining data packet to pipeline followed by waiting of acknowledgement. Once the final acknowledgement is reached, name node is connected to tell if the final file write operation is completed. These are the functions included in the write operation in HDFS. Okay, now let me go through about YARN. It means yet another resource negotiator. YARN is a framework on which MapReduce works. YARN performs 2 operations that are job scheduling and resource management. The purpose of job scheduler is to divide a big task into small jobs so that each job can assign to various slaves in a Hadoop cluster and processing can be maximized. Job scheduler also keeps track for which job is important, which job has more priority, dependencies between the jobs and all other information like job timing. And the uses of resource manager is to manage all the resources that are made available for running of a Hadoop cluster. Okay, what is the features of YARN? Multi-tenancy, scalability, cluster utilization and compatibility. These 4 are the features of YARN. Hadoop common or common utilities. After the completion of YARN, now we are going to see what is Hadoop common or common utilities. Hadoop common or common utilities are nothing but our Java library and Java files are, we can say, the Java scripts that we need for all the other components present in Hadoop cluster. These utilities are used by HDFS, YARN and MapReduce for running the cluster. Hadoop commonly verify that hardware failure in a Hadoop cluster is common, so it needs to be solved automatically in a software by Hadoop framework. Topology of the network affects the performance of the Hadoop cluster when the size of the Hadoop cluster grows. In addition to the performance, one also needs to care about the high availability and handling of failures. In order to achieve this Hadoop cluster formation, make use of network topology. Typically, network bandwidth is an important factor to consider while forming any network. However, as measuring bandwidth could be difficult, in a Hadoop, a network is represented as a tree and distance between nodes of this tree is considered as an important factor in the formation of Hadoop cluster. Here, the distance between 2 nodes is equal to sum of the distance to the closest common ancestor. Hadoop cluster consists of a data center, the rack and the node which actually executes jobs. Here data center consists of rack and rack consists of nodes. Network bandwidth available the process varies depending upon the location of the process. That is, the bandwidth available becomes lesser as we go away from. Process on the same node. Different nodes on the same rack. Nodes on different racks of the same data center. Nodes in a different data centers. Okay, these are the Hadoop common or common utilities. Now, the features of Hadoop. Let me see what are the features of Hadoop. Open source, highly scalable cluster, fault tolerance is available, highly availability is provided, cost effective, Hadoop provided flexibility and easy to use. These points are the features of Hadoop. Okay, this is the end of this video. As I have said before in the introduction, we have gone through these topics. It means what is big data, applications of big data, what is Hadoop, subject projects of Hadoop, Hadoop architecture, topology in Hadoop, and features of Hadoop. We have gone through all these topics in this video. If you want to know more about this topic, it means if you want to know more about the Hadoop in big data, or you want to know clarity about the Hadoop in big data, means please kindly go through any websites or Google or YouTube and go through and search through the topic and learn more about this topic. Thank you.